Okay na yung groupings nyo. Ano? Salamat. So those two topics that were assigned to you, yun na yung research niyo for the semester. Okay? And later on, schedule natin yung pagpe-present ninyo. Your presentations will only take you, let's say, you budget 20 minutes. At the most, 20 minutes. Minimum, say, 15 minutes. Ang purpose naman natin sa mga research ninyo so that at least for at least one or two topics, thorough yung yung knowledge niyo. And then later on, you will share to our groups, FB, yung set of slides niyo. So as much as possible, make your slides rich in information. I won't require you to write any manuscript anymore. Yung document file, wag na. Puro PowerPoint presentations lang tayo. But as I've said, make it rich with information. So maglagay kayo ng mga caption, notes. But of course, don't forget to write the source. No? You have the liberty to copy paste yung mga text. I give you that liberty kasi as long as you mention your source, and if you have copied it that hindi nyo pinaraphrase, yan na yun, parang enclose nyo doon sa double apostrophe. Parang ganun. Alam nyo naman na yun. I don't know what referencing are you familiar with. Ako kasi nasanay ako sa Harvard referencing. So we'll just use Harvard referencing. So as early as now, sanayin nyo na yung Harvard, yung familiarity niyo, yung familiar na kayo dun sa Harvard referencing. Okay? Maraming mga references sa web. How you implement Harvard referencing. Very important ito sa ating discipline kasi so that maiwasan nyo yung tinatawag na plagiarism. Okay? There's nothing wrong with getting so much information sa web, mga journals, as long as you implement yung Harvard or particularly referencing. Always put the source. Kasi writing the source, you are giving merit dun sa kung saan yung kinuha yung information. Okay? Na-download nyo na ba yung lecture notes natin for today? Na-download nyo na? Okay, before we discuss that lecture, mag-answer muna tayo ng mga problems doon sa previous lecture natin, doon sa lecture number 6. Okay? So far, anyone has something to raise or ask a question? Nasubmit nyo na, yung marami na rin nakasubmit doon sa doubly reinforced beam. Wala namang issue doon sa pagsagot niyo noon. Okay, so more or less, you know already the way how to design doubly reinforced or singly reinforced beams. Depending on the moment force that your beam is going to carry. Okay? We account for the loads that the beam has to carry. the dead loads and live loads. And then we multiply the necessary what factors na 1.4, 1.7. Ano tawag natin sa mga yan? Load factors. We actually magnify the the the, the loads that we deem that our member has to carry. The factor for live load is greater. What is the reason why we why we multiply a greater factor for our live loads? Because there's a greater uncertainty na dun sa live loads natin. And that's why we are implementing a larger load factor. Okay? And then for the capacity, we also account for that. But from the nominal capacity of our beam, we multiply a reduction factor. So two-way tayo. No? We magnify the loads and then we reduce the computed capacity or nominal capacity with a reduction factor. So two-way. Yeah. So in that case, what's our purpose? Why we do that? So that we will have a safer structure or safer member, beam member. Okay. Okay. Now let's solve some problems. You can turn off your videos now. There. See. Now I'll share this. Share. Okay, do you see it? Do you see the Excel file?
Yes, sir.
Yes, sir.
Okay, good. It's very convenient to use the Excel file in computations. It's just that you have to be familiar how to use it and then how to write formulas. Okay, so let's start with problem 6.1. It says if the beam in example 6.1 were reinforced with number 9 bars, could it safely carry an additional live load of 1 kip per foot? Okay, that's the question. So let's look at the beam. So your beam, your length is what? 28 feet, 14 feet, 14 feet. Yun yung mid-span length. So L is 28. Of course, our fee here, reduction factor, is 0.9. Now, in example 6.1, our F prime C is 3, our Fy is 60, KSI. Okay? What is KSI? Hindi nyo pa alam itong KSI. KSI is kilopounds per square inch. Okay? Itong 3 KSI, that's also 3,000 PSI. Baka malito kayo, no? Sir, bakit 3 lang yan? 3,000 PSI yung nakalagay. Kasi yung 1,000 is K in kilo. Kilopounds per square inch. Okay? Now, it says here, because originally, the bars here, reinforcing bars, are for number 8. But in this problem, it says we're reinforced with 4 number 9 bars. So instead of number 8, number 9. So therefore, area of steel would be 4 square inches. Okay? Mas maliit to dun sa example 6.1 kasi number 8. Okay? Now, D is 24 inches. Okay, saan natin nakuha yung 24 inches? In here. No? The center line of the reinforcing bars. And then your B is 13 inches from the drawing. Okay? Now, we use the same raw, which is 0.01282. Now, computing for the resisting moment, applying the formula. Okay, where did we get this formula? This formula. No? Okay, there's the formula. Okay. So, ito yung formula natin. Look at how the formula in Excel was assembled. So, this formula, phi, ito yun, phi 0.9 times rho 0.01282 times Fy 60 KSI, so that's 60. And then B is 13. D squared, 24 squared, times 1 minus 0.59 times F3. F3 is rho. Ito. Fy times Fy over 2. Okay? Do you see the formula? Do you see it? Medyo maliit, no? Pero nakikita nyo ba? Yes, okay. Salamat sa nag-thumbs up. No? So, anyway, we are just following this formula. Yeah? Now, answer there is 4,399. Now, that is actually keep inch. No? Kasi inches yung ginamit natin dun sa BD squared. Okay? Now, if we want to express that in keep feet or keep foot, you have to divide that by 12. So for this formula is this divided by 12. So you get 366.65. Okay. Now, it is asking, it says, could it safely carry an additional service line load of 1 kip per foot? Okay, this one, originally, the MU is 287. So if it's only 287, wala kang additional na 1 kip per foot, it can carry it. No? Kasi 366 to. This is 366. Okay? But if we add 1 kip per foot, okay, of course, we have to multiply that by 1.7 because it is a light load. Okay? Service, sabi niya, additional service live load. So, our formula for a distributed load is, remember, WL squared over 8. That's the maximum moment for a simplified beam. Okay? I want you to memorize that already. if you have a simply supported beam, to get the maximum moment that a uniformly distributed load uh, is, okay, the formula is WL squared over 8. And it occurs at mid-span. Okay, remember that. So we have to apply that. No? So we add that 1.7, the factor, load factor, times 1, because that's 1 kip per foot, times the length, which is 28, squared divided by 8. Okay? So in that 287 originally, if that additional service load is applied, it becomes 453.6. This is kip foot. Okay? Now, kindly compute this by yourself, no? Itong mga values dito, write the units so that you can confirm. Okay, ito kasi L squared, so magiging feet squared yan. Yung 1 kip per foot. So, the resulting unit for this part in here, it should also be kip foot. Itong 287, kip foot na yan. Na, from example 6.1. So, comparing these two, okay, what will be your answer? Could it safely carry the additional live load? Anyone? Of course, we just compare the two, no? Ito yung load niya, ito yung capacity ng beam mo. So the answer is no, cannot carry, no? Do you agree? Any question for this problem? Question? So you understand it. Understood? Malinaw? Okay, good. If I don't hear any response, that means it's a yes. No? Pero that's good, no? Nagta-thumbs up kayo. Now, let's answer 6.2. Now, 6.2, it says, find the resisting moment of a 16 by 33 inches rectangular beam section, reinforced for tension with 6 number 8 bars. The effective depth is 30 inches. Fy is 60 KSI. F prime C is 3,500 PSI. Excuse me for a while, no? Dali lang. Give me a Okay. So 6.2, we find the resisting moment. So how do we find the resisting moment? Of course, same formula. Ito pa rin ang formula natin. Okay. So B is 16 inches. Ito yung 16 by 33. This is your H. So take note, your D is different from your H. Now, D is effective depth. That's the center line of the reinforcing bars. H is total height. No? Yan yung concrete part. And then Fy is 60 KSI. F prime C is 3,500 PSI. But in KSI, that's 3.5. Of course, your phi is 0.9. Now, the area of the steel, this is 4.74. Okay. Because we have 6 number 8 bars. You know already how to use the table provided for you. No? So check nyo lang yon. If we have 6 number 8 bars, total area is 4.74 square inches. Okay? Any question for this? So given na yan, you get your raw, okay, from, because you already have reinforcement and your area of reinforcement and your B and D. So, ito yan. No? Area of steel divided by the product of B and D. Okay, that's your raw. So, may raw na rin kayo. Applying the formula, ito, this formula, okay, phi, that's 0.9, raw, that's 0.009875. I-call nyo lang siya, no, from the formula. Just call it from here. So Fy is 60, B is 16, D 30 squared, multiplied by the quantity 1 minus 0.59 raw. This is raw. And then Fy over F prime C. Okay? So, meron na kayong MR, resisting moment. And then to express that in kip foot, you divide that by 12. Divide it by 12, you have 575.99 kip foot. Okay? So, anyway, ito yung MR natin. No? Now, we are equating that to MU because that's where we will base yung answer for 6.3. Okay? It says, if a simply supported beam of the section given in 6.2 were to span 33 feet, what is the greatest imposed uniform load WU it could support? Okay? Now, our formula, kasi uniform load tayo, no? Again, since we are considering a simply supported beam, again, your formula for a simply supported beam is WU L squared over 8. Now, sir, bakit WU? Kasi yun ay tanong eh. What's the greatest imposed uniform load? Okay, so we have this formula. Now, isolate WU, work out the equation. Your formula would be MU times 8 divided by L squared. Okay, this is just algebra. No? Now, we apply the formula. MU, ito siya. So, MU, that's 579.99 575.99 times 8 divided by the square of the length, okay, which is 33 feet squared. And your answer will be 4.23. What will be the unit of this one? Anyone? Ano ang unit niyan? It would be kip per foot. Okay? Kasi itong M niyo is kip foot divided by feet squared. Okay? So merong matitirang feet sa baba. Yung feet sa taas, nung MU, magka-cancel. Okay? So effectively, you'll get kip per foot. That's the unit for a distributed load. Particularly for this problem, it's uniformly distributed load. Okay, any questions so far? Question? Okay, Eliza.
Sir, to clarify lang po, yung WU is for distributed load po, diba? Pero pag concentrated load, PU yung, letter P yung
Yes,
niya,
correct.
symbol. Pero technically, it both refers to load lang naman.
Both. This one was mentioned uniform load, WU. So, iba yung formula sa
kapag concentrated.
sa concentrated load. Iba. Okay?
Sige, sir. Thank you po.
Okay. Welcome. Well, anyway, what is the formula for concentrated load? Maximum moment due to a concentrated load at midspan. Anyone? Sandali, hindi ko rin matandaan eh.
Hindi ko sure, sir, kung PUL over na yun.
Dali. Yung dati kasi, it's a special, it's a special formula. Sige, later, dadaanan natin. So let's go back dun sa Excel file. Now, 6.3, tapos na natin. Now, we proceed to 6.4. Ay, wala dito yung problem. It's not written here. Okay, this is the problem. 6.4. You see it?
Yes, sir.
It says here, a rectangular beam section 14-inch wide, okay, with an effective depth of 24 inches, is reinforced with 8 number 10 bars. Okay, Fy is 40 KSI. If the effective depth of the beam were to increase to 30 inches and the area of tensile steel reduced to 7.62 inches, would the altered section be more or less moment resistant than the original? Kanya. Let F prime C is 4,000 PSI. Okay? Naintindihan niyo yung problem? Tignan natin. So, tingnan na lang natin yung given dito. So, the B is 14 inches. Yeah. And then effective depth is 24. Uh, number 10 bars. Number 10, if you check that sa table, your area of steel would be 10.16. Okay. And then Fy is 40 KSI. F prime C is 4,000 PSI. Okay. Yes. Sige pa natin dito para, yeah, it's much better. Okay, so we already have area of steel, and then we also have B and D. So we already have value for your raw, or AS over BD. That's our raw. No? So we'll be able to get yung resisting moment. No? Resisting moment, which is already multiplied na rin to dun sa reduction factor. Okay, so you'll get 7,212 kip inch. Divide that by 12, you get 601.01. Okay, now it is asking if the effective depth of the beam were to increase to 30. So from 24, magiging 30, and then mare-reduce yung area to 7.62. What will happen? Okay, now we will just observe the change in the resisting moment, okay, or the ultimate moment that it can carry. Okay, now tingnan nyo rito. From 24 gagawing 30. So if this happens, ano ang nangyayari? Lalaki yung section ng concrete, okay? But pinaliit yung steel. Okay? Pinalaki yung concrete, pinaliit yung steel. Now, what happens to the steel ratio? Lumaki yung steel ratio natin. Sorry, lumiit pala. Lumiit yung steel ratio. Okay? But we did not change the material. No? Ganun pa rin yung steel strength. And then you also have the concrete 4 KSI. And then the computed moment, resisting moment, is 612.39. Okay, don't get confused yung MU. We are just equating our MU and MR. So nagbago, di ba? Lumaki pa rin yung resisting moment niya. Would you say na nakatipid ba tayo? Nakatipid ba to? Nilitan mo yung bakal, nilakyan mo yung concrete. Okay, it boils down to the price of concrete and steel. Okay, kapag scale yan, perhaps malaki yung savings mo. Na pag mura yung pag-produce ng concrete. Okay, depende sa economic study. Okay, any question? Okay lang. Let's have a CR break. 5 minutes now. Yeah? Sige. Okay. Any question for problem 6.4? Let's proceed to problem 6.5. Problem 6.5, it says, what is the maximum compressive force resultant that could develop in a beam of 13-inch width and 28-inch depth, effective depth, where Fy is 60 psi and rho is 0.0100. Okay, that is the question. So you're given B, the width is 13 inches, the effective depth is 28 inches, and then Fy is 60 psi. Okay. The rho is also given. Rho is 0.0100. So if you're given rho, then you can approximate the area of steel. Okay, because of the formula, rho is equal to AS over BD. So to get the area of steel, you just multiply B times D and then times rho, okay, by cross multiplication. Okay, I hope you are getting that. Iba rho, let me write that formula. Symbol for rho, asan yung rho dito? Hello? Can't find the rho. Yan ang mga symbols. Rho. Rho is equal to AS divided by B. Okay, so by cross multiplying AS is equal to rho times B times D. Okay, that's how we got this 3.64 square inches. Okay, so having that, because you are asked, it says maximum compressive force resultant. Dalawa yung formula natin for the compressive force. Pwedeng ito because we are equating the tensile force with the compressive force. Compressive force, that's 0.85 times F prime C times A times B. But we don't have value for F prime C, di ba? Okay, but we have AS and FY. So to get the value of this, we can equate that with this. Okay. Question. Sir, bakit i-equate natin compressive sa tension force? Equivalent, ito, equivalent na compressive force siya. Ito, equivalent tension force. So, we are equating that because yung assumption natin, summation of forces along the horizontal is 0. That's why we have the resisting moment, which is the couple. The couple brought about by these two forces, C and T. C and T are in opposite direction. Okay, that is the couple equal to the resisting moment. But you are not asked for the resisting moment dito, di ba? You are asked for either this or this because they're just equal. For this one, for the tension, we can just multiply Fy and As. Okay? So the answer is 218.4 kips. Okay? Nagets natin? Did you get it? Okay, good. Let's proceed to 6.6. Excuse me. Sorry. Let's look at 6.7. 6.6. Okay, this is 6.6. Now, let me just cut it. There, so that you can readily see it. Okay, it says a simply supported beam 22 feet long is reinforced for tension with 6 number 9 bars. Okay, so when I say this number 9, parang nakakatuwa kasi you don't have to look at the table. If it's number 9 bars, 1 bar is 1 square inch. So right away, your AS is 6 inches squared because you have 6, okay, number 9 bars. Now, factored loads, including self-weight. When it mentioned that right away, that means all the service loads were already multiplied by their load factors from 1.4, 1.7. So ito na yon. Ito na yung WU. Okay? WU na yan. Pag U stands for ultimate. Ultimate. It's already multiplied by 1.7 and 1.4. 1.7 for live load, 1.4 for dead load. So that's 6 kips per foot. Where is that? So WU is 6 kip per foot. Therefore, your MU is 363 kip foot. Now, what formula we will use? It's still WU L squared over 8 because it's mentioned here simply supported beam. Okay? So, it is asking whether enough ba yun. Is the section acceptable? Ayan. Okay, if you compute it, already have your B and your D, and then your area of steel. So your rho is can be computed, which is 0.03. Now, and if you compute for the resisting moment, multiplying it, the nominal multiplied by 0.9, you get 5,089 inch. So your MU is 424.15. Okay. Now, comparing this, ito at saka ito, parang pwede, no? Pwede siya. But we have to check the raw because raw max is 0.0232. Yun yung maximum steel ratio. Ano ulit yung reason bakit sa code nililimit niya yung raw? Why is the steel ratio being regulated or it is kept to a maximum? Merong specification. Anyone remembers? Bakit nga merong diyan? Merong provision for raw? Kasi ang answer dito, it says no because the raw, which is 0.03, is greater than raw max, which is against the code. Ano ang purpose ng code? Bakit siya nagsaset ng maximum? So that hindi crowded yung yung reinforcements natin. That will block yung distribution ng concrete doon sa paligid reinforcements natin. No? I told you about what happened, yung findings nila doon sa Hyatt Hotel sa Baguio. Mga professional yung mga nag-design. They check the design kung may problem. Parang wala naman. Doon sa construction, kasi if there will be problems sa construction, especially where the beam and column meet, masyado ng crowded. No? So as much as possible, i-control dapat yung raw or the steel ratio so that things like those hindi mangyari. Kasi pag merong mga voids sa part ng reinforcing structure, reinforced concrete structure, okay, humihina yung supposedly strength niya. Even if we've already instituted yung mga load factors, capacity reduction factors, there's a chance na hindi mo pa rin ma-reach yung required capacity. Okay? So the answer is no, even if this one is greater than this one. Okay? Now we'll proceed to 6.7. Let's look at the problem. Okay, ito yung problem. Stop share muna ako lang. Parang ako nag-hang siya. Oh, okay. So we are here in pinagbabayad ako. Kaya ayaw maalis. Hindi na. At ko yan. There. Yan. So, we have this problem. It says the only load to be imposed on a simply supported beam of 18-inch with 38-inch effective depth spanning 40 feet. So yung length mo is 40 feet. Is a concentrated load, dead load at midspan. Okay, ito yung kanina. No? Sabi ko mababanggit natin. So, how great a concentrated service dead load can the beam safely support at this location if F prime C is 4,000 psi and the 60 ksi tension reinforcement is designed to a ratio of 2/3 raw max. Okay? So, yung ratio natin is 2/3 of the raw max. Yung raw max natin, if you look at the table, okay, that's 0.0213. So therefore, if we implement 2/3 of this raw max, that's 2 times this divided by 3. So that's 0.0142. Okay? So if we have that, we have your AS to be the product of B times T and your raw. Ito, ano? Ito yan. Isa, dalawa. Those three parameters. 18 times 38 times 0.0142. So that's your steel area. Area of steel, that is 9.71 square inches. Okay? Fy, F prime C are given. Length is 40 feet. So it is asking how great a concentrated service dead load can the beam safely carry, safely support this location. So first, we will have to compute for the resisting moment due to the section. Okay. So again, we implement the previous formula, no? This formula. Okay, that's formula. So we have that here. Okay, divide that by 12, you get 1,452 kip foot. Okay, so the natin galing 1.16 kip per foot. Okay. Walang sinabing ano rito. uh, uniformly distributed load. Okay. Okay, nandiyan pa kayo. Okay. Sorry. Ayan. Sabi ko na nga ba eh, something wrong eh. Hindi ko na screen share. Ayan. Pag ganyan, magsalita kayo. Minsan hindi ako nakatingin sa chat box eh. Nakafocus lang ako sa ano. Ayan, nakita niyo na. Ayan. Okay. This is the problem, no? Ulitin ko kasi hindi yun. So, meron na tayong B, D, A of steel due to the rho, which is 2/3 of the rho max. Yung rho max, makikita nyo dun sa table sa appendix. No? Given yung Fy and F prime of C. So, you'll see this 0.0213 dun sa table na yan. Multiply by 2/3, you get 0.0142. That's how we got this AS. Fy, that's given already, 60 KSI. Okay, and then F prime C, 4. Of course, yung phi, pareho lang, 0.9. Length is 40. Overall depth is 44 inches. Now, there are two components for the ultimate moment. The first component is the dead load. The dead load is the weight of the beam itself, which is computed here. WU, which is actually the first component of the moment. This WU is or has this formula. 1.4, that's the factor. 18 and 44, that's the dimension of your section. Okay, 18, that's the B. 44 is the overall depth, okay, of your beam, which 44 inches. So we get the cross section of that, and then this 150 is the unit weight of concrete. Na 150 pounds per cubic feet. Okay? And then divide that by 144. What do you think is the 144? This is the conversion from inches. Ito kasi 8 at 44 inches siya. So, yung first, that's 12. And then another 12. So, yung sa denominator mo is 144. 12 times 12. Okay, and then divided by 1,000. 1,000 is the conversion from pounds to kilopounds. So effectively, your WU is 1.16 kip per foot. Kilopounds per foot na tayo. Okay? Did you get that? Any question? Might be tricky, no? But the way I explained it, I hope you got it. So, any question? Nakuha niyo naman yan? Okay. Good. Okay, yung pagkuha nun, try to look at how it was computed there. Kung paano nakukuha ito. Saan nanggagaling yung 144 tsaka yung 1,000. is 144 again when you are converting yung dalawang inches sa numerator. And then this 1,000, yung namang pounds. You're converting pounds to kilopounds. Okay? So you get 1.16 kip per foot. So resolving for MU1, the ultimate moment given by the self weight, that's 231 kip foot. Okay? This is kip foot. Now, this 1,221.16, if we have the ultimate moment, kasi ang tinatanong sa atin, what would be the concentrated load at midspan that the beam can carry? So, yung ultimate moment, which we are equating to the MR or the resisting moment, okay, we have this formula. So we know this already and we know MU1. We can get MU2. So this is now MU2. The formula for MU2 is equal to MU minus MU1. So that's equal to this. MU minus MU1, you get MU2. So this should be the moment that your service dead load at midspan should carry. Or that's the maximum concentrated service dead load. So now how do we apply that? If you check the formula, okay, the formula for the maximum moment with a loading concentrated load at midspan is P. P, that's the concentrated load. So PL over 4. Okay. M equals PL divided by 4. Okay. So if you will work out the equation, your P, therefore, P, that's equal to 4 times M divided by L. Tama? So, eto yon. Okay? Wala yung 8 dito. So, that's 4. So, 4 times M. In this case, yun ang MU2 natin. Divided by L. L is 40. So therefore, our P is 87.23 kips. Nasundan natin? Any question? Class? Okay, good. Follow. Okay. Any question? Question? Miss Micah, do you have any question?
Okay na po.
Very good. Hazel? Hazel, do you have any question?
Wala po, sir.
Okay, very good. Joanne? Miss Joanne?
Okay na po, sir.
Very good. Sige. Basilio,
Yes,
how is
sir.
it? Okay naman ang susundan mo?
Yes, sir.
Good, good. Ella?
Yes po.
Okay, good. Sige. Now, we can take a longer break. Let's have a 15-minute break. before we continue to solve 7.1, 7.2, and 7.3. Okay? Okay, 15-minute break tayo.